Okay, guys, this is just a recap of what we did last time with your parent graphs and how we went through all the different kinds of transformations that you're going to be required to know how to do. So this just kind of breaks it down to each individual little part. So you have vertical translations. That means you're going to take your parent graph and you're either moving it up or you're moving it down. So we've got up here and down there. So remember, this is like the Y part of your of like the little vertex thing we were talking about. The Y part is here on the outside. So if I had the parent graph of x squared and I wanted him to go up 2 units, I would need to make that x squared plus 2. If I wanted him to go down 3 units, I would make him x squared minus 3. So personally, I think vertical translations are the easiest because it's exactly what you would think. You just tag it onto the back end. Okay, now the next one we're going to look at right here is the horizontal translations. That's your side to side, going left and right. So if you'll notice, what they do is it's inside with the x. And what's strange about it is the opposite sign of what you would think. So if you're going to go right, like if you were thinking about a graph, positive numbers are over here, negative numbers are over here. So if you're trying to move your graph over here to the right side, you don't add, you actually subtract. You have to do the opposite sign. So when you're moving to the positive direction, you're going to put a minus in there. That's the reason we talked about changing the sign. If you're going to the left, over where negatives normally live, you don't put a negative in. You got to change that sign. So, well, that doesn't really correlate. Left just means to add. So let's just make up 2 examples of that. Say we started with absolute value function, and we want to go left 4. If we want to go left 4, left is where the negative numbers normally live. So I'm not going to put negative. I'm going to put positive, but it's got to be inside. That's where my side-to-side movement happens. If I want to go right 2 units, then right is over here where the positive numbers normally are. That's where you normally graph. Well, it's the opposite sign. So I would do minus whatever the number is, 2. Okay? But that goes to when we were pulling out our vertex the other day, and we will do that here in just a minute. When we pulled out our vertex, if it was inside the grouping symbols, we always changed the sign. Okay, now the other easy one that we did was the reflection. And the only one we did, though, we did this top one. If it's reflected in the x-axis, that's where you get a negative on the outside. So if you see one that says negative, and then you've got x squared plus 1. That means instead of being a U that smiles, he's a frowny face. So think about it, he's up here at 1, but he's frowning. You reflected him down. So it basically just flips over the x-axis. We're going to hold off on reflecting in the y-axis for right now. Okay. The other thing we did mention was the vertical stretches and compressions. Remember I told you you could use the A and it kind of acted like slope? For right now, that's the way we're going to approach it. Just know that there is some quirks with that for more complicated functions. So if you have something like y equals 3, absolute value of x plus 1, and then minus 2. So you know that your vertex is at -1, -2, but this 3, we were saying A equals 3. Well, A still equals 3, but that is a vertical stretch. It's a stretch because A is bigger than 1. So if A is bigger than 1, you call it a stretch. So you would come down here and you'd be, okay, let me go to 1, let me come down here to -2, and from there, I'm going to go up 3, 1, 2, 3, over 1, but you're going to mirror image him over there because you're supposed to know the absolute value is a V. So you got to set him up to get your graph. Okay. If you have a fraction, remember I told you fractions made it fat? That's called a vertical compression. So, guys, it works the exact same way. They're just using different language for integers versus fractions. So if you've got y equals 1/3, and then we've got x plus 2 squared minus 1. Okay, your vertex is still the same place. You do it the same way. -2, -1. A is still -1/3, or excuse me, positive 1/3.
Miss Lamont, are you still here?
Y'all gotta love Hilda, don't you? Okay, 1/3 is a vertical compression. All right. Now, I would love to tell you that acted like a normal slope, but this is where it gets weird. If you do it like what we've been talking about, you're going to get really close, but it's not going to be exact. That's your vertex, and yes, it's going to be the U shape, but you can't say up 1/3. That's, again, it'd be real close, but it's not. You have to treat it like this is the rise. Put this 1/3 needs to be the rise part of slope, and 1 needs to be the run. That's the complicated version. I'm not giving y'all any of those today to do for practice. If you see any, you can skip that one. But basically, you go up 1/3 and go over 1. So that kind of lets you know how fat it would be. But again, that's a little bit more complicated. You can at least tell me that if A is a fraction, that's a vertical compression, whether you graph it or not. Okay, this is what I'm needing you to be able to do. All right, you're going to have a little group work that you need to do. First thing is you got to be able to write the equation given the written description of a transformation. And I'm not necessarily sure these are in the same order as the group work, but it's all on the page. So here's 2 examples. I'm going to tell you that it's absolute value function, and it's translated up 4 to the left 5 and a vertical stretch of 2. So you've got to remember where that goes. Now, if you'll think of what that function looks like, remember if we were just going to set it up with the generic look, that's the generic look. Okay, so when we say up 4, that's the K part, and that's going to be exactly what you think. Up and down is logical, and it's straightforward, nothing weird. And then it says left 5. Now, if you think about that, if you go left, that's where negative numbers live, so you've got to do the opposite when you stick it in here. So it's going to be plus 5. So left is add, right is subtract. So if you didn't catch that earlier, that's the shortcut. Left, add, right, subtract. Okay. Now the A value, it says a vertical stretch of 2. And it's using the word stretch because 2 is bigger than 1. So just put your 2 out here and you're good. Okay, then we've got the square root function is translated 1 unit to the right, and it's reflected over the x-axis and vertically compressed by a factor of 1/3. Okay, well, let's see if we can just write this. This reflection over the x, that means we need a negative. The vertical compression of 1/3, we need a 1/3 in the place of a. Now we're doing the square root function, so I've got to do square root of x. And this is talking about I'm moving it side to side, so that's underneath with x, so give me some extension there. Right means to subtract, so I'm going to subtract how much? 1. It didn't say anything about moving up and down, so there's nothing hanging off here on the back end. Okay, so you are done with that. So you'll have several problems that ask you to just take the words and turn it into a function. Then you've got to be able to take the graph, or excuse me, take the function and actually graph it. And this is what we did last time. So it would probably help you if you came in here and you said, okay, what's my vertex? And my vertex is change the sign, keep it the same. What is your A value? Your A value is -1, which means we're reflecting it. So if we come over to 1, 2, 3, and then we go 1, 2, 3, 4. Now I didn't ask you what the parent function was, but I could. If I ask you what the parent graph was, you should be able to tell me that that's f of x equals absolute value of x. That's what the parent graph of this is. So you know it's going to look like a V. But this -1 makes him turn upside down. And that is like a slope of down 1 over 1. So you could check him out. Those are like 45-degree angles. All right, then you got a vertex over here of -1, -4. Your A value is 2, which means that since A is 2, that is a vertical stretch of 2. And if we wanted to, we could say the parent graph is going to be f of x is x squared. So we know he looks like a little u. So we're going to go to -1, and we're going 1, 2, 3, 4. That's where we are. And since that's a 2, we can treat it just like slope, up 2 over 1. Up 2 over 1. But don't make a v, make a u. And that gives you your little function. Okay. If you wanted to over here, you could say, instead of saying a is really 1, and the negative just means that it's reflected over the x-axis. Okay. Now, next little part that you need to be able to do is take the graph and end up with the actual function. So, all right, let's just kind of go in some kind of order. This first one right here. Where is the vertex? This vertex is at -2, -4. And what is this parent graph? Hopefully it made sense. This parent graph is a little u, so that's an x squared. So that means, I'm going to leave a little space here because I haven't analyzed my little a value yet. I've got x in here, but I'm going to have to put my -2 inside, which means I got to change signs. My square goes out there, and my -4 comes on the back end. So this is very similar to what we did at the beginning. Now, I need to look for slope. So if I look at this, does it look like it's up 1 over 1? It does not. This looks like, and I can't really even see what the grid is, but it doesn't look like it's an a value of 1. He looks a little skinny. So if it was an a value of 1, it'd be up 1 and over here, but he missed. And it's not up 1 over 2 because he'd be there. Is it up 1 over 3? 1, 2, 3, and over. That looks pretty good. Looks like 3. So let's put a 3 in there. All right, if you come over here to the second one, hopefully you recognize that this is a V, so this is absolute value. And from there, the first thing that I would think would catch your eye, that he's upside down. Now, what's our vertex? Our vertex looks like we're at -1 and up to, let's see here, if this is 2, then this has to be 4. So be careful with your scale, okay? So if I went -1 is my x, I've got to change it because the x value always changes signs. The y value is always the same. Now I need to look at my a. Let's find slope. He went down 1 and over 3. So that's a -1/3. You can do that on absolute value and it works just fine. It's the curves that you can't do that on. Okay, now this last one. This one, if you remember, he looks like the cubic function. He's just not quite perfect because if you remember what you learned for a cubic function, went that way. So hopefully it clicks with you that he's been flipped over. So our little function here has a negative on it. It's been reflected. But this right here is kind of, it's not a vertex. You can call it a little anchor spot. It's that little flat spot. That's what we're going to treat as the vertex. That's our little hinge. So if this, every box is 1, according to, if that's -5, every box is 1. So I went over 1 and I'm up 2. So that's going to give me x -1, and we're doing the cubic equation, so put your cube, and then plus 2. Now I need to analyze, we got to get this done. I need to analyze my slope, but my slope, look here, it went down 1 over 1, so it just needs to be a negative. That's just like a little -1 out there. Y'all practice, see what you can do. You can write questions all over it, but give it a shot, okay?